x minus 2 not equal to 0 and x plus, or not x plus, not, 9 not equal to 0.
So it's denominators anywhere with an X.
Uh,
Yeah.
then x minus 6 and x minus 2,
Yep.
which would
So
be
X cannot
2
be 2, X
and
cannot
x
be
cannot be 6.
6. Good. Okay. Now it's really two separate problems from here. I'm going to just reframe it here. Make it a little smaller. It's really two separate problems. At the top, it's the bottom. Let's work on the top first. What is the common denominator on the bottom? The least common denominator.
The least common denominator, um, you get that by multiplying x minus 2 by 9 and 9 by x minus 2. So they
Okay,
can
so you're
become,
doing the bottom first. That's fine. So it's 9
yeah.
x minus 2. That's fine, yeah. And you just have to figure out what am I multiplying them by? Okay, 9 and 9, x minus 2, x minus 2.
Yeah.
So like you said, it's 9 times 36, whatever that is, over 9x minus 2. All right. And so do you think you'll get a calculator on this? Well, you said part of it you will,
Yeah, I think
but
it's there. Let me check the thing. I think we'll be allowed a calculator for this because only part that says without calculator is the graphing rational functions without a calculator. So I'm assuming we probably have one. But yeah.
okay, so it ends up being 324 plus 4x minus 8. So whatever that is. And then what's the common denominator on the top?
The top it would be um, you have to multiply each side by like multiply the left side by x minus 6 on the top and bottom numerator and denominator, and multiply the right by 6 on the numerator and denominator.
It's a little messier. So it's x minus 6 over 6 times x minus 6 minus x minus 2 times 6 over 6 times x minus 6. And then a lot more to do here on this one. So when you foil that's x minus 6, you get x
That's to be
squared
x
minus,
squared minus 12x plus 36, yeah.
perfect. The next one you have to
And
make sure you
then
distribute
that's
that negative to
minus,
both. Yep,
yeah, then you'd be minus 6x plus 12, yeah.
right. And so now you gotta like, okay, gotta combine like terms. You got x squared minus 18x plus
Ah,
48
what do you need?
over 6x minus 6. And on the bottom here, 316 plus 4x over 9 times x minus 2.
And now you would need to multiply by the reciprocal.
Yeah. And I'm kind of looking at this x squared minus 18x plus 48 to see if it
Fact.
factors. Doesn't look like it does, but really looks like it might. So this one's just really, really messy when you're all done. It's just x squared minus 18x plus 48, 6 times x minus 9, 9 times x minus 2. Probably a good idea to put things in parentheses. 4x plus 316. And then you start looking for things that might cancel. And there's not much. The 9 and the 6 do cancel, so there's a 3 and 2. You could factor 4 out of the bottom here. X plus 158, 79. But that doesn't really do much. So
Yeah, because
you're
it can't cancel with anything else there.
yeah. So if 3 out in front, you could put a 12 out in front, x minus 2, x minus 9, x plus 79. There's your final answer. So what we really did there was the objective, like, simplify complex fractions, which includes all the stuff that it leads up to that. Do you want any other problems or move on to rationals?
I think I'll move on to rationals.
Okay. All right. Do you want more of like test questions that are multiple choice? So I'm really,
Yeah, because sometimes
I do think,
she does give
yeah.
some like that. No.
All right, give me just a moment.
Yeah, especially since on our final review, this chapter alone isn't on there, so might be a great idea to also add
Yeah,
some
so the
multiple
reason
choice.
this part of the course really lends itself well to multiple choice. And here's like a first problem. It says identify any points of discontinuity. So discontinuity are two things. They are holes, they are vertical asymptotes.
So any point where you stop like the domain, pretty much. Like if you were
Yeah,
to stop for a hole and stop it.
at least at this point, yeah. So I mean, it's not really a difficult question once you know those things, but you have to know those things to be able to do the question.
Let's see. You need to factor the bottom of it. So would it be, let's see, X. Would it be B?
Let's B. Very good. All right, so let me throw a bunch more at you here.
All right. Let me write the equation. All right. X. And then vertical. So there is a hole at x equals -5.
Okay.
Then narrows it down to A or B. Then the asymptote vertical one is at x equals -5 and x equals -3, but it can't be the same as the whole. So it would have to be A.
It is A. Now, what is the Y value? What is the Y value of the hole?
The y value you have to plug it in for x. So then if you plug in -5, it would be all right, it would be it would be 7/2.
Yes. Very good. Okay. And this is kind of the way I think the teacher might structure it. I don't know anything, but yeah, that's something to think about. All right, here is another problem for you to look at.
Yeah, let's see if there's horizontal toast in the toe. So that's comparing the degree. Which one is at top? It's would it just be 3/7? So it'd be
Yeah,
A.
it's an equation though. It has to be an equation, just
Yeah,
like the
well, y
last
y
one.
equals yeah y
Yeah.
equals
Good. All right, here we go. It says simplify the rational expression, state any restrictions on the variable.
All right, I got A,
Okay.
y minus your y cannot equal 7.
Yep, looks good. Okay. Um, so for this one, let's make this one free response for the moment. Give me the equations for the vertical asymptote and the horizontal asymptote.
Okay. The vertical asymptote would be x cannot, or x equals 2. And then the horizontal asymptote would be, oh, right, that's 20. Right, y equals -2.
Okay, now I want you to make a quick sketch on your paper there of the vertical and the horizontal asymptote. And then I want you to decide where the graph goes, whether it's in the like region 1, 2, 3, and 4. You might have to test a point or two for that.
Yeah. Let's see. Oh, God. No.
So just to be clear, what I'm looking for is like x equals 2, y equals -2. And then like what you're not sure of is like, well, does the graph in the top left, top right? So you might
Yeah,
test a point. When you test a point, and it could be anything, you'll find that it ends up being
yeah. I did
something
end up
like
finding
that.
the first part of it, the top part, where it goes through the first, third, or first,
Okay,
fourth, and third kind of. Yeah, I did find
cool.
that part.
All right, so here is, I mean, we'll just do, is it okay if we do a few more of these before we do
Yeah.
some graphing? Because there's some good stuff in here. Um, Here's another one on domain.
All right, so see the domain of the rational expression. Don't set notation. Okay, so y.
How are you doing on this one?
Um, I'm not stuck because I
So,
got, yeah.
so this one I know they teach it another way, but when there's only one way to factor the three and three up and x, and of course seven's only got one factor.
I put 3x minus 4x plus 3.
You got to get to seven. It's got to be seven and one or one and seven.
Oh, got it. Mm, mm. So then would it be
You're setting
C?
each of those not equal to zero.
Because the domain based. And if it's in set notation, that means whatever it cannot equal, right? So
Yeah, I mean, you're probably not going to see set notation the way
she
you're,
did show like one example, like one time we'd used it in notes, but other than that, we haven't really used it. But she might maybe give one question with it, maybe. So would it be C in this case because of the Oriental
well,
method as well?
the numerator can be zero. It's just the denominator.
So
So
the
it's not
numerator would factor to x plus 5x minus 5.
right, but you don't care where that's zero. You only care where the denominator is zero.
So then it would be D where if you were
Yeah,
to set it equal, then yeah, it would be
it's
negative D.
only where the denominator is zero.
Got it.
Okay, so here's another one. Um, you may have to make a single fraction if you're not sure how to do it, but it is related. It's similar to what we've done, but maybe you haven't seen one of these in a while.
What is this? Main range, okay, G of L, um, um, uh, B, B. All right, let's see which one. Mm, wouldn't it be A?
So it is vertical asymptote at x equals minus 5, that's for sure. Uh, the horizontal asymptote is this number here. Now you can get that by making a
Oh,
single fraction, which we should briefly look at because I believe there could be a question on that. So you're multiplying the top and bottom by x plus 5,
oh yeah, right. Then we're going back to like so the prodding it kind of
but you
how to
don't
get
have to do
that.
that. I mean, the vertical asymptote is, I'm sorry, the horizontal asymptote is that number, but you'll see it as well when it's in this format. So it
Got it.
becomes minus x. This becomes minus x minus 5
So
minus
then it
x.
would be y such that y cannot equal -1,
Yeah.
which would make it B.
Yep. Good. All right. All right. So this one, another good one for us to look at. So this is free response. Uh, Identify the zeros and the vertical asymptotes of this. And then we'll sketch a quick graph of it.
Okay, zeros and vertical asymptotes. So the vertical asymptote is x equals 2. The zero. Wouldn't the zeros be 4 comma 0 and negative 1 comma 0?
You got x minus 4x plus 1 like that?
Yeah.
Okay. Yes, those are the zeros. So negative 1 comma 0 and 4 comma 0. Now, how about the actually, yeah, give me the vertical asymptote. We're gonna add one more thing in here too.
So that would be x equals 2.
Okay. How about the slant asymptote?
The
Did we cover
slant
that?
asymptote. Yeah.
Okay.
2. Mm,
I'm not on camera.
uh,
Yeah.
I, yeah, maybe we should probably review how to find the slant asymptote. Oh yeah, right. You do the synthetic division and then do it with the new. Yeah, now I remember. You take the concept of you take the vertical asymptote and divide it by the
Yeah.
numerator using synthetic division.
If you go ahead and do that, you only care about the first two terms here.
1, -3, -4, C 2, 1. Would it be x minus 1? Or yeah,
One,
good. Wouldn't it
2,
be
yeah. So
y
it'd
equals
be
x
y
minus
equals
1?
x minus 1. Yeah, good. Really good. Okay. Um, Now, yeah, free response. Give me the domain and the range.
The domain. Oh wait, can you scroll up a little bit?
Sure.
Great,
Yeah.
excellent question. All right. The domain or range. Okay. If there's no holes, the domain would be negative infinity to 2, not including 2, then 2 to positive infinity.
So
And
it's just broken up by the vertical asymptote, right? I
yeah,
think that's
so
what you
negative
said.
infinity 2, yeah.
Okay.
Then
Now
the
the range is
range,
a little bit harder. You really need a graph of the range. So that's where I was gonna have you make a quick sketch. X minus 1.
oh yeah, that's the slant asymptote, so you need to,
Yeah, because we don't know, and this one you might have to graph. It ends up being this and this, so you would have to graph this for the range.
and you would have to, I guess, calculate the maximum and minimum, which
Yeah.
she says you can use the calculator for to
Yeah.
calculate the maximum and minimum of it.
Why don't you grab your calculator and do that for this one, just to confirm.
All right,
Um, and then
so
we'll see.
Let me see the maximum.
Apologies, I gave you the wrong graph here. It actually does not look like this. Uh, it's got this shape. So it's actually everything, all real numbers.
All right.
All right, so it's kind of a new one. We're gonna go through all the things on the list here. So I know your teacher has a nice table, but we want, uh, and this is the order you should do it in: holes, vertical asymptote, domain. Believe it or not, domain comes then. Um, horizontal asymptote. Uh, range really comes from the graph, but you could do it here if you wanted. X-intercept, Y-intercept. And so if there is a hole, you want that as an ordered pair.
Got it. So, actually, I got a hole at -4, -1.
Yes, that is correct. And it breaks up the domain and the range as well. Very good. All right. Are there any vertical asymptotes?
Yeah, it's x equals -4.
Well, there can't be both a hole and an asymptote at the same
So there
place.
isn't one.
There is none. Yeah.
So a vertical asymptote cannot be a part of a hole, like a hole, not a part of a
Well, I mean,
asymptote.
there could be both, but in this one, if it's at the same spot, remember it
So is that
cancels
this?
out. It
Yeah,
becomes
so
just x plus 3.
got it. So the domain would be -infinity to
So
-4, and then
before you go
-4
much
to
further,
infinity.
you might well, yeah, you can do the domain. The domain's based on the holes in the vertical asymptotes.
Yes, I got -infinity to -4, not including -4, and then from -4 to infinity.
Very good. And
And
then
then
the
horizontal
graph here,
asymptote.
it's pretty straightforward. It's something like this.
Got it. Alright, horizontal asymptote would be 1, y equals 1.
Remember, it reduces to this form, so that there actually is none. There's it's just a straight line.
So if it cancels out, if the vertical asymptote and whole cancel out the negative x minus 4, then there is no horizontal asymptote. So
Well,
there's neither
it's just a
each.
line. It's not a
So it's just
rational
so
function
it's just
anymore.
a line. Oh, got
Yeah,
it.
yeah.
And then 5, the range would just be negative infinity to -1 union -1 to infinity. So just stopping for the whole.
Yep.
And then the x-intercept would be at -3, 0.
Okay, agreed.
The y-intercept would be 12. The y-intercept would be 0, 12,
Nope, nope.
12 fourths. Or no, just simplify that.
Use the reduced form.
Oh, so 3, so 0, 3.
There you go. Okay. I'm
So
glad
you
we did
use the
that one.
reduced form. Once you reduce
Yes,
it from the whole and the vertical asymptote, you
exactly.
just use that form for the
For
rest of it.
everything,
Got it.
for everything here, use the reduced form.
So just for the whole chart, you wouldn't get the reduced form yet because you still need to find the whole. But after that, you do the reduced form.
Yeah. Okay, let's do kind of the same thing for another one here. This one's a little bit more difficult. Same list though. It's the same list. Holes, vertical asymptote, domain, um, horizontal asymptote, range, x-intercept, and y-intercept. So you do have to factor first though.
All right. So x equals. One second. All right. So let's see. X plus 1. Top would be. So for the final factored form that or factored version of it, I would get, and then for the numerator, it'd be 5 times x minus 3x plus 3, and the denominator would be x plus 4, x minus 4.
Okay, does anything cancel?
Nothing cancels.
There's no
So
holes. So you can use either the factored form or the original form to do the rest. So,
the
some things are
vertical
easy.
the vertical asymptote would be y equals or x equals -4 and x equals 4.
Good.
And then the domain would be -infinity to -4 union -4 to 4 union 4 to positive infinity.
Okay.
The
What
horizontal
about the
asymptote would be 5 or y
okay.
equals 5.
So to
The
do the range, you are going to need to graph this. So we'll come back to that. But can
And
you give me the
then
x-intercepts and the
the
y-intercepts?
x-intercept would be, would it be 3,0 and -3,0?
How about the y-intercept?
That would be 0,5.
Nope.
Oh wait, actually, never mind. I thought that was multiplying by that. Never mind. That would be, so that's minus plus, so that would -9, -21 over, uh, so 0 comma negative, or 0,45 over 16.
Yeah, and I guess that does not reduce, even though it now looks like it should. All right, very good. Now I want you to make a graph of this. You know, not for me, but more for you. I mean, there are two vertical asymptotes, but you need to find the range. The only way you can find the range is to look at the graph of this. And you can graph either the original or the factored form.
Minus 3 plus 3 x plus 4 minus. All right.
For the rough sketch that I have here
Yeah,
of
there's
the,
kind of the three lines to go through. There's,
so
yeah,
you have
that
to find
one,
this point because
that, and the two in the minimum there. Kind of.
yeah, because we know what the other side is. This is 5 to infinity. And it's in minus infinity to whatever this number is.
Let me find the maximum there. All right, I got 45/16.
Oh, so you're doing it by hand? Yeah, and that's fine.
No,
I
I
mean
did it
that's
on the I did it on the calculator. I got X
yeah,
was
no,
negative
right.
2.484 or something like that, but that was
Yeah,
basically zero.
yep, that's really good.
Then
Okay, that is it for that. All right. Any questions here before we close out for today?
no, not really.
I would rework these examples, maybe a few others. For most of the problems, you can go through this entire list. And then there's a lot of let me put this in the chat here so you can see what I searched for. That was my Google search to get a bunch. There's a lot. You can find a lot of questions on there um,
Got it.
for this. So, all right, we're just gonna stop a little early today, Karthik. Appreciate you doing that. So we're gonna